Matrices are everywhere. They are in our computers, they are in our phones, they are even in the air we breathe. Okay, maybe not the air, but they are almost everywhere. A matrix is a powerful tool for organizing and manipulating data. Think of a matrix as a grid. This grid is filled with numbers. These numbers are arranged in rows and columns. Each number in a matrix is called an element. Each element has a specific position. This position is defined by its row and column. The size of a matrix is determined by its number of rows and columns. A matrix with m rows and n columns is an mxn matrix. Matrices have numerous applications in various fields. In computer graphics, matrices are used to create realistic three-dimensional images. They help rotate and transform objects on the screen. In cryptography, matrices secure our online communications. They help to encrypt and decrypt messages. Matrices are also essential in engineering and physics. They solve systems of equations. These equations describe the behavior of complex systems. In economics, matrices analyze market trends. They optimize resource allocation. Just like numbers, matrices can be added, subtracted, and multiplied. Adding or subtracting matrices is straightforward. Ensure both matrices have the same number of rows and columns. Then, simply add or subtract the corresponding elements. Multiplying matrices is a bit more complex. The number of columns in the first matrix must be equal to the number of rows in the second matrix. The resulting matrix will have the same number of rows as the first matrix. It will have the same number of columns as the second matrix. In the realm of numbers, the inverse of a number is its reciprocal. Multiplying a number by its inverse always equals 1. Similarly, the inverse of a matrix when multiplied by the original matrix results in the identity matrix. The identity matrix is like the number 1 in matrix operations. It has ones along the diagonal and zeros elsewhere. Finding the inverse of a matrix involves a series of steps. These steps include finding the determinant, the adjoint, and then dividing each element of the adjoint by the determinant. The inverse of a matrix is a powerful tool. It helps solve systems of linear equations. It unlocks secrets hidden within data.